Imagine a vast, untouched wilderness. The Siberian taiga, a place of deep forests and silent rivers. Then a blinding flash, a wave of heat, and a sound like the end of the world. On the morning of June 30th, 1908, something extraordinary happened in the skies above Siberia. A colossal explosion, now known as the Tunguska event, flattened millions of trees over an area larger than London. What caused this cataclysmic event? Over a century later, the answer remains elusive, shrouded in mystery and speculation. The Tunguska event stands as a stark reminder of the immense power of the cosmos and our own vulnerability beneath its gaze. Join me as we journey to the heart of this enigma, exploring the science, the theories, and the enduring mystery of the Tunguska event. The Tunguska event was not your everyday explosion. It released an estimated 10 megatons of energy, equivalent to 1,000 Hiroshima bombs. The shockwaves circled the globe twice, registering on seismographs thousands of miles away. Witnesses described a fiery object streaking across the sky, leaving a trail of dust and smoke. The air grew unbearably hot, followed by a thunderous roar that shook the ground and shattered windows hundreds of miles from the epicenter. This remote region of Siberia was sparsely populated, and thankfully there were no confirmed human casualties directly attributed to the blast. However, the event left an indelible mark on the landscape, felling trees like matchsticks in a radial pattern outward from the explosion's center. The Tunguska event immediately captured the world's attention. What could have caused such a massive explosion in one of the most remote corners of the globe? The Tunguska event sent shockwaves through the global scientific community. Theories abounded, ranging from meteor impacts to volcanic eruptions and even secret weapons tests. However, the remote location and limited technology of the time hampered early investigations. It wasn't until 1927, almost 2 decades later, that a Soviet expedition led by Leonid Kulik reached the epicenter of the blast. Kulik, a mineralogist, had heard tales of the event from local Evenki people who believed it was a visitation from the god Ogdi. What Kulik found stunned him. Millions of trees lay flattened, radiating outward from a central point. The devastation was unlike anything he had ever seen. Strangely, there was no impact crater, deepening the mystery surrounding the event. Kulik's expedition marked the beginning of decades of scientific inquiry into the Tunguska event. Researchers from around the world descended upon the Siberian taiga, eager to unlock the secrets of this enigmatic event. Early theories focused on the possibility of a meteor impact. However, the lack of an impact crater and the unusual pattern of the tree fall presented challenges to this hypothesis. Some scientists proposed that the meteor had exploded in the atmosphere before reaching the ground, explaining the absence of a crater. Others explored alternative explanations, including the possibility of a cometary impact. Comets, composed largely of ice and dust, could potentially explode in the atmosphere with tremendous force, leaving behind little physical evidence on the ground. The lack of definitive answers only fueled further speculation and debate within the scientific community. Section 5. The comet hypothesis. The comet hypothesis gained traction among some scientists. Unlike rocky meteoroids, comets are often described as dirty snowballs composed of ice, dust, and volatile compounds. These icy interlopers could vaporize explosively upon entering Earth's atmosphere. Proponents of the comet theory point to the Tunguska event's timing. It coincided with the peak of the Beta Taurid meteor shower, which is associated with the debris stream of Comet Encke. Perhaps they suggest a fragment of this comet, unseen and undetected, collided with Earth on that fateful morning in 1908. The comet hypothesis explains the lack of an impact crater, as the icy body would have vaporized high in the atmosphere, releasing its energy as a devastating airburst. However, skeptics argue that such an event should have left behind a more significant trail of meteoric dust in the atmosphere, which has not been definitively identified. Section 6. Cosmic Showstoppers. While the comet impact theory remains a leading contender, other, more unconventional explanations have been proposed over the years. From the depths of space to the realms of science fiction, the Tunguska event has sparked the imagination of scientists and laypeople alike. Some have suggested that the Tunguska event was caused by an antimatter meteor. Antimatter, a hypothetical substance with the opposite charge of ordinary matter, annihilates upon contact, releasing tremendous energy. However, there is no scientific evidence to support the existence of antimatter meteors in our solar system. Others have ventured into the realm of the paranormal, proposing that the Tunguska event was caused by a UFO crash or even a black hole passing through Earth. While these theories capture the imagination, they lack any credible scientific basis. Section 7. Echoes in the night sky. Despite over a century of investigation, the Tunguska event remains an enigma. However, recent scientific studies have shed new light on this mysterious event, bringing us closer to understanding what transpired in the Siberian skies on that fateful day. In 2007, an Italian research team conducted a detailed analysis of Lake Checo, a small shallow lake located about 5 miles from the epicenter of the Tunguska event. They found evidence suggesting that the lake may have formed in the aftermath of the explosion, possibly as a result of a fragment of the impacting body striking the ground. Further analysis of sediment samples from the lake revealed the presence of microscopic particles that could be remnants of the extraterrestrial object. While not conclusive, these findings provide tantalizing clues that could help to unravel the mystery of the Tunguska event. Section 8. Cosmic Threats. The Tunguska event serves as a stark reminder of the ever-present threat posed by objects from space. While events of this magnitude are relatively rare, they are not without precedent in Earth's history. In 2013, the Chelyabinsk Meteor, a relatively small asteroid, entered Earth's atmosphere over Russia. The resulting airburst, while much smaller than the Tunguska event, released the energy equivalent of approximately 400 to 500 kilotons of TNT, causing widespread damage and injuring over 1,500 people. These events underscore the importance of planetary defense and the need to develop effective strategies for detecting and mitigating the threats posed by near-Earth objects. Space agencies around the world are actively engaged in efforts to track and catalogue potentially hazardous asteroids and comets. Section 9. An enduring enigma. The Tunguska event continues to fascinate and intrigue us over a century after it occurred. Despite decades of scientific inquiry, the exact nature of the object that exploded over Siberia remains a subject of debate and speculation. Was it a stony asteroid that exploded in the atmosphere, a fragment of a comet that vaporized upon entry, or perhaps something else entirely, defying our current understanding of the cosmos? The mystery of the Tunguska event serves as a reminder of the vastness of the universe and the many secrets it still holds. It is a testament to the power of scientific curiosity and our relentless pursuit of knowledge, even in the face of seemingly insurmountable mysteries. As we continue to explore the cosmos, we can only wonder what other enigmatic events await our discovery.